So we're going to say, we're going to answer the question, what is the third root of 8.1 subtract and minus the third root of 8? Okay, so we do know the third root of 8, that should be just a 2, but we don't know this guy. So let's use our knowledge of linear approximations. Okay, so here we have an f of a plus delta x minus an f of a. Okay, so automatically we can determine what is our function and what is our a and delta x respectively. Okay, so first of all, our function, so f of x should just be the third root of whatever's in there, of our x. Okay, so now our a value is just going to be an 8. So a is equal to 8. And then we have that a plus delta x is equal to 8.1. So a plus delta x is equal to 8.1. So if we subtract the a to the right side, then we get that delta x is equal to 8.1 minus a. And we figured out that a is equal to 8. So 8.1 minus 8, that gives us a delta x of 0.1. So see how this is pretty small, right? That's what we mean by small. Like not like 100 or something, because then that would make our approximation very inaccurate. Okay, so anyways, from here, what we're going to do is find basically the difference, alright? So this is what we're trying to find, which is equal to our delta f, right? That's our change in f, and we know that our change in f is approximately equal to f prime of a, and then times that delta x, okay? So what we're going to do is find so we know what delta x is, right? We just found that. That's 0.1. So we already have that. We can check that off. But we don't know f prime of a yet. So what we're going to do is find f prime of x from this function here. Okay, we're going to find f prime of x and then plug in our a value of 8. Okay, let's do that on the next slide. So we have the function f of x is equal to the third root of an x, okay? So another way we could rewrite that is x to the 1/3, so we can use power rule, right? So f prime of x is going to be 1/3. We're going to bring that down in front. Then we have x to the negative 2/3 power if we subtract away a 1, right? So that was power rule there. And now what we're going to do is just plug in our a value. A is equal to 8, all right? So f prime of a, or 8, is 1/3 times 8 to the negative 2/3 power. So that's going to be a 1/3 times 8 to the 2/3 power on the bottom. Okay, and this is going to turn out to be a 1/3 times, and 8. The cube root of 8 is 2, and 2 squared is a 4. So we have a 4 on the bottom. So f prime at 8 is equal to 1/12. All right. So that is not all. But because we have to plug this guy, this is f prime at a, or 8, so now we have to plug that into this formula here. So to get our delta f, we have to have f prime of a times our delta x. Okay, so to get that, we're going to plug that guy in. So we have delta f is equal to 1/12. Well, we're going to plug that in for f prime at 8, which is our a. Right, and then our delta x. Okay, so this is going to be 1/12 times a 0.1, and this turns out to be something like 0.0083. Okay, so that's basically it. What we can rewrite this part as is just like the difference that we're trying to find, right? So the third root, or the cube root of 8.1 minus the cube root of 8 is about equal to 0.0083. Okay, and so that's it. That's our answer for this question. And here's a little bonus step. Since we know that this is equal to 2, we can basically just rewrite it as the cube root of 8.1 minus 2 is about equal to 0.0083. So if we wanted to solve for just this guy, we would just add that 2 over. Okay, and we get that the third root of 8.1 is about equal to 2.0083. Okay? So, fun fact, now you know that the cube root of 8.1 is about equal to 2.0083. Good to know.